All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you should have x plus 6 times x minus 2. For the math knowledge question, our point is negative 3, 7, and it's shifted down by 3. So that's a y change of negative 3, and it's shifted to the right by 7. So that's an x change of a positive 7. So if we start with our point negative 3 and we add 7 to our x, and then 7 and we subtract 3 from it, that's going to give us the point 4, 4. So C would be your answer. So if you have one of the other options picked, that's because you didn't apply it to the correct x or y value. You got to make sure that going down goes to your y value and going to the right goes to your x value. So we're looking at lesson 16 today. We're going to be looking at complex fractions, abstract equations, and division of polynomials. So hopefully you'll understand how to do all three of these after the lesson. Complex fractions, abstract equations, and division of polynomials were touched on in Algebra 2, so you may remember it from there. If not, hopefully the more we practice them, the more it'll jog your memory. They're not difficult. You just have to make sure you know what you're doing on each one. So we want to simplify these. So it's called a complex fraction because there's more than one fraction bar. On this one, there are actually 3 fraction bars. There's one here, and one here. So we need to simplify it so that we only have one fraction bar. And the way you do that, you start at the very bottom. So this part in blue is going to change, but everything else is going to stay exactly as is. So we're going to have x over a plus m over, and then we need to make this one fraction. So the common denominator is going to be a d, and then the b is going to get multiplied by d, and the c already had a d in its denominator, so it doesn't get multiplied by anything. Okay, from there, we need to simplify this term right here. So I'm going to come over here. When we are dividing by a fraction, so m divided by bd plus c over d, that's the same thing as saying m times the reciprocal, d over bd plus c. And so if you multiply those, your x and your a stay the same, and you're going to end up with plus md, or dm, over bd plus c. So some people just think of this as taking the current denominator and moving it up to the numerator, and this stays the same. If you want to think of it that way, you can. That's what's going to happen, basically. Now we're going to have to combine these two into one fraction. So the x on top stays as is, and then your denominator is going to be bd plus c. So the a gets multiplied by bd, the a gets multiplied by the c, and then the dm already has the denominator, so it doesn't get multiplied by anything. And then again, you're going to multiply by the reciprocal, and so this part down here is basically going to get moved up to your numerator. So you're going to have bdx plus cx all over abd plus ac plus dm. And so this will be your answer. You do want to check and see if you have the same letter in all of your terms. We don't, like these c's can't cancel because we're adding here. So don't try and cancel terms just because they look the same. You can only cancel it if it's in every single term. Okay? So we can't simplify that one, so we just have to leave it as is. Looking at this one, we have 2 fractions over 2 fractions. On these, the easiest thing to do is to get one fraction in your numerator and one fraction in your denominator. So in our numerator, the common denominator is going to be an x squared. And so the a already has an x squared, so it's just going to be a. And then the b has 1x down here, so it needs to get multiplied by another x to make it so it'll have an x squared in its denominator. For the denominator, this common denominator is going to be cx squared. So the m is going to get multiplied by c, and then the k is going to get multiplied by an x, because it only has one x in its denominator. From there, we're going to multiply by the reciprocal of our denominator. So a plus bx over x squared times cx squared over cm plus kx. Okay, and then from there, before you multiply across, we actually want to see, does anything cancel here or here? There is an x and an x, but those don't cancel because there's that plus sign. So only if they're identical do you cancel them. But on the other side, this x squared and this x squared will cancel. And so when we multiply, we're going to have a times c plus bcx all over cm plus kx. So a c is in 3 of the terms, but it's not in this last one. So we need to leave it as is because there's nothing in all of our terms that'll make it simplify. So that's how you do complex fractions. Now we're going to look at abstract equations. So the reason they're abstract is because your answer is just going to be a jumble of variables. So the first thing you want to do is to distribute the v. You want to get rid of your parentheses. So it's like it's v over 1. So v gets multiplied by a, but it doesn't go to the x because it's only in the numerator. And then same thing on the next term, bv over cm. Okay? And then the pieces that are in our denominator are c, m, and x. So I'm going to multiply every term by cmx. And so on this first term, there's nothing in the denominator for this to cancel with. So we just have cmxy. On this next term, the x's will cancel because there's one that would be in the numerator and one that would be in the denominator. So we'll have a cmv. And then on the last term, both the c and the m cancel, and so we will end up with just bvx. So that's one way that you can do it. Some people prefer to do a different method from here instead of doing what I just did. Either way, you still should get that same equation. So if you want to do it another way, just check and make sure that this equation here is the same. And then we're looking for c. So here is one c, and here is another c. We need to put them both on the same side of the equation. So I can subtract this term over to the left side, and then it'll just equal bvx. From there, you want to factor out your c. So we'll have mxy minus amv. And then if you solve for c, you're just going to divide by what's in the parentheses. So you're going to have bvx over mxy minus amv. And so that would be your answer for that one. Okay. So now we're going to look at dividing polynomials. We want to divide x cubed minus 2 by x minus 1. And then we want to check it by adding the 2 together. So this is like long division. The x minus 1 is going to go on the outside, and the x cubed minus 2 is going to go on the inside. But we need to make sure to put placeholders. So we started with an x cubed, so our next term would be an x squared, and then we would have an x, and then we would have our constant. So if you're missing any terms, you need to make sure to put your placeholders so that you don't forget to do those. So what you're going to do, x times what will give me x cubed? Well, x times x squared would give me x cubed. So now we take x squared and multiply it by x minus 1. So x squared times x minus 1 is going to be x cubed minus x squared. From there, you have to change your signs because we're going to be subtracting. So make them the opposite of what they are. And so these will cancel. And then I'll have 0 plus a 1, so just x squared. Now, x times what would give me x squared? Well, that's going to be plus x. And so x times x is x squared, and then times -1 is negative x. And then from there, you need to change your signs. And so these cancel, and I have 0 plus a 1x, so that's just x. Now, x times what would give me x? A 1. So now we do 1 times x minus 1. Then you have to change your signs. And so these x's cancel. And I have -2 plus 1, which is -1. So the way that you write your answer, you have x squared plus x plus 1. And then you can either do minus 1 over x minus 1, or you can do plus a -1 over x minus 1. Either one of those is fine with me, whichever one you prefer. Okay, so that's your answer. And then it says check it by adding your quotient and your remainder fraction. So we're going to take this and add them together. So if we're going to add them, that means we need to make it so they have the same denominator. So the denominator would be x minus 1, and the x squared plus x plus 1 is going to have to get multiplied by x minus 1. And then the minus 1 doesn't get multiplied by anything because it already has the x minus 1. If you distribute, you'll get x cubed minus x squared plus x squared minus x plus x minus 1, and then minus another 1, all over x minus 1. And then these terms cancel, and these terms cancel. And so we're left with x cubed minus 2 divided by x minus 1, which is exactly what we started with here. And so we know that that answer is correct. And that's what it's asking you to do. So that's how you can check these. You don't have to check them on your test if you don't want to, but that is how you go about checking it to make sure that you got your answer correct. So your homework tonight, you get to omit number 11 and 12. Those are 2-column proofs. You did 2-column proofs in geometry, so you don't have to worry about doing those this year. So make sure to do the other questions tonight for homework so we can go over any problems you have tomorrow.